Hello friends, till now we have discussed diode basics, open circuit test, and we started the applications of diode. In that applications we have completed the rectifier part, and I also solved previous year questions on this. After this rectifier we are moving on to clipper circuits. In clipper circuits there are three types of circuits: series clipper, shunt clipper, and two level clipper. In this video I am going to discuss about these three circuits, and I will solve some gate previous year problems. So guys, first I will explain the definition of clipper circuit. So let us assume that there is a clipper circuit. Whenever we are giving an input waveform to the clipper circuit, the name itself indicates it clips some part of the waveform. If it clips the positive part of the waveform, this is the output. It can clip completely or only some of the positive part. It is the output waveform. This kind of clippers are called as positive clipper. And similarly, if it clips only the negative side, it is called as negative clipper. If it clips the both sides, this is the output waveform. It is called as two-level clipper. So basically what it is doing is, it is changing the shape of the circuit by this action. So it is also called as wave shaping circuit. So if you see the definition guys, a clipper is a device which limits, remove or prevents some portion of the waveform above or below a certain level. In other words, the circuit which limits the positive or negative amplitude or both is called as clipper circuit. Clipper circuit. So guys, here what I will do is, there are many clipper circuit. I will analyze one or two clipper circuits, and for remaining circuits I will give shortcuts. By using this shortcut you can draw any waveform by just seeing the clipper circuit and input waveform. Apply that shortcut and draw any waveform. In gate exam you will use this shortcut. So let us proceed further. So friends, I already told that there are three kinds of clippers, that is series clipper, shunt clipper, and two-level clipper. So what is a series clipper? So this is the basic clipper circuit guys. Whenever the diode is connected in series with the input voltage, it is called as series clipper. Whenever the diode is connected in shunt, it is called as shunt clipper. So this is the basic definition guys. Diode should be connected in series and resistor should be in parallel or shunt. Here resistor is in series and diode is in shunt. So this name basically indicates location of diode. Similarly here also, since diode is connected in series, it is called as series clipper. So now what I will do is, I will analyze series clipper and I will analyze shunt clipper. So you can tell directly the answer of two-level clipper. So first we will analyze the series clipper. So it is the basic diode circuit guys. This is the input voltage we are applying. So if you are watching my videos from the starting, what is the first step we should do? Yes, open circuiting the diode. So I have drawn the equivalent circuit guys here. This is the first step we should do. What is the next step? We should find the voltage across P type, voltage across N type, and we should calculate the VAC, that is voltage between anode and cathode. See, the voltage across cathode, this is anode, this is cathode. It is VB. Assume this as positive voltage. The voltage across cathode is VB. Assume this is an ideal diode. So whenever the voltage at an anode is greater than VB, then the diode will be in on condition. Is this clear guys? When VAC is greater than 0, then diode will be in on condition. Since voltage across C is VB, whenever voltage across A is greater than VB, then diode will be in on condition. If diode is in on condition, see output voltage, input voltage, they both are in parallel. So output voltage will be equal to input voltage. If you see the graph here, is it appearing? Wait. See, at starting positive voltage is applied across the diode. So input voltage started increasing. Whenever the input voltage reaches VB, what will be the condition of diode? It will be in on state. So if the diode is in on state, what will be output voltage? It will be equal to input voltage. So from this point to this point, V input is greater than VB. So V output follows V input. This is the waveform above VB. Now we will see what will happen if diode is in off condition. See guys, this is the equivalent circuit under off condition. If the diode is off, the output voltage V0 is directly equal to the VB. So see, what is the condition for diode to be on? VA should be greater than VB and it should be positive. If it is negative, diode will be off always, and in the positive cycle it should be greater than VB for the diode to be turned on. See, this is the negative cycle. During negative cycle, the diode will be completely off. So what is the output voltage? VB. We got VB here. And while coming to the positive cycle, diode will be on only if VA is greater than VB. So whenever the input voltage is greater than VB, the diode is on. So here to here, input voltage is greater than VB. And when the diode is off, output voltage follows the VB. So this is the analysis of series clipper, guys. Moving to the shunt clipper. So what is the first step you should do? For analyzing this circuit, you should open circuit the diode. So this is the equivalent circuit, guys. If you observe carefully here, C is connected to minus VB. So you should connect voltage greater than minus VB across A for the diode to be on. So what is the voltage greater than minus VB? If this is minus VB, this total voltage is greater than minus VB. So whenever this whole cycle up to here is applied, diode will be in on condition. So what is the equivalent circuit of on condition? Just short circuit the diode, because I am telling that it is an ideal diode. So if you short circuit the diode, what will be the output voltage equal to? Minus VB. Don't worry guys, this is just for your understanding. There is a simple shortcut for the clipper circuit. By seeing the circuit, you can draw the waveform. I will explain you after this. So this is the on condition. Next, while coming to off condition, up to here it is on. So here to here, anode voltage is less than cathode voltage. So it will be in off state. While in off state, what is the output voltage? It will follow the input voltage. So here to here, the output voltage will follow the input voltage. Up to here it is in on state. So output voltage equal to minus VB. Here also minus VB. So this is the analysis of shunt clipper, guys. So series is completed, shunt is completed. Now moving to the parallel, that is, two-level clipper. Friends, before going to the two-level clipper, I will tell you the shortcut how to write. From that shortcut, we will solve this kind of question. So the shortcut is, if output is connected to the negative terminal, negative part will be clipped off. See, here output is connected to the negative terminal, so negative part is clipped off. If output is connected to the positive terminal, then positive part will clip off. It's the shortcut, guys. See, here output is connected to the negative terminal, and there is also another point. Here there is a reference voltage VB. So first what you will do is draw VB here in the input side. So if it is connected to the negative side, the negative voltage below VB will clip off. Shortcut is completed. Now tell me here, output is connected to the positive side. So positive part will clip off. The whole positive part will clip off, or there is some limit for it? Yes, there is some limit. See, here voltage is minus VB. So first draw minus VB across it. Now there are two pots, above minus VB, below minus VB, which will clip off since it is connected to positive, the positive pot, that means above minus VB. The whole circuit will clip off. This total circuit will be clipped off. See, in series clipper also you draw the voltage VB. There are two pots, the positive pot which is above VB and the negative pot which is below VB. See, I am taking VB as reference now. So when if I take VB as reference, this is the positive with respect to VB, this is the negative with respect to VB. So since this output voltage is connected to the negative side, this total negative voltage is clipped off. So this is the shortcut, guys. Now let us draw the output waveform for this two level clipper. See, if this is the input voltage, I am drawing VB1. Let this be VB1. And I am drawing VB2 also. Let this be VB2. Since it is minus, I am drawing this as minus VB2. See here. See only this leg. Here V0 is connected to the positive of the diode. So the part which is above VB1 will be clipped off. Why? Since it is connected to positive, positive part will be clipped off. So see here. The part above VB1 is clipped off. Now see this leg. Since it is connected to negative, the part below VB2 will be clipped off. See, this is VB2. With reference to VB2, this is positive. The below one is negative. So since it is connected to negative, the below one is clipped off. See, it is VB2. The below one is clipped off. So this is the shortcut, guys. In the next slide, I will give some 5 to 10 problems, and by using this shortcut, we will solve all the problems. So if you see this two circuit, guys, this is the input voltage applied and this is our clipper circuit. So by using shortcut, we will write the answers directly. So if you observe here, V0 is connected to the positive side. So what will happen? Positive part will be clipped off. Which positive part? Above reference voltage. What is the reference voltage here? 0. So since this is the reference voltage, the positive part will be clipped off. So what is the output? Since this is clipped off, this is the output waveform. If you observe here, first draw the reference voltage. It is 2 volt. So I am drawing 2 volt here. So with reference to 2 volt, this is positive part and downward is negative part. So V0 is connected to the positive terminal of the diode. So what will happen? Only positive part will be clipped off. So what is the output voltage now? Positive part means above 2 volt is clipped off. So this is the output. This is 2 volt. This is minus 8 volt. So this is the next question, guys. There is a sinusoidal waveform. It is applied to this circuit and this circuit. He is asking us to find the output voltage waveform. See, here reference voltage is minus 1.5. So first draw the minus 1.5 here. Minus 1.5. So when taking reference minus 1.5, this is the positive voltage. This is the negative voltage. Next, see, output is connected to the positive of the diode. So what will happen? This entire part is clipped off. So what will be the output voltage now? Minus 1.5. This. Minus 1.5 is the reference voltage. Since output is connected to positive part, the whole positive part is removed. Which positive part? When compared to minus 1.5, this everything is the positive part, while taking minus 1.5 as reference. And this is the negative part. So don't confuse, guys. While taking 0 as the reference, this is positive part, this is negative part. But while taking minus 1.5 as the reference, this whole part is called as positive part. And this is called as negative part. So like this I am writing. Next, tell me the answer for next circuit. the same voltage is applied here. So what is the first step you should do? You should draw the reference voltages. So I am drawing the reference voltage. First reference voltage is plus 10. So let this be plus 10. And second reference voltage is minus 10. Let this be minus 10. Now see guys, this output voltage V0 is connected to the negative part of the diode. This indicates that the whole negative part is clipped off. Which negative part? Negative part which is below 10 volt and which is below minus 10 volt. This question is just given to confuse you guys. Actually this leg is not required. Why? Because the negative part which is below 10 volt and the negative part which is below minus 10 volt, both are same. If this negative part is clipped off, indirectly this is also clipped off. Do you got my point? So this is just given to confuse you guys. So what will be the output voltage? The voltage below plus 10 is completely clipped off and the voltage below minus 10 is also clipped off. So this is just given to confuse you. So this will be the output voltage. This is the plus 10 volt. Next question guys, this is the two level circuit. See what are the reference voltages? Minus 1 volt and minus 2 volt. So I am drawing the minus 1 and minus 2 here. Minus 1 and minus 2. So while considering this leg, output voltage is connected to positive part of the diode. So the part which is positive is clipped off. Next, while considering this circuit, it is connected to the negative part of the diode. So the diode which is negative, the part which is negative is clipped off. This thing. So guys, what I am doing is, while comparing with this leg, I am taking minus 1 as reference. So when I take minus 1 as reference, this will become my positive, this will become my negative. When I take minus 2 as reference, this whole thing will become my positive and the down thing will become my negative. So that's it guys, very simple. So what is the output voltage? It will be like this. This is minus 12 volt and this is minus 2 volt. See the whole part above minus 1 is clipped off and the whole part below minus 2 is clipped off. So this is the output voltage guys. So this is the next question guys. It is somewhat tricky question. Why? Because in our previous question there is only one resistor here, but I added another resistor here. So what will happen? See, when the first step is we should open circuit the diodes, right? We completed the first step. If this is the equivalent circuit, what is the voltage here? Some voltage will be there at the cathode side, but we need the voltage here. What is the voltage here? Is it Vi? No guys, here there are two resistors. So apply voltage division rule. Here voltage will be Vi by 2. This is the difference between previous question and this question. So we should analyze everything with Vi by 2 now instead of Vi. So is it is Vm, it is minus Vm. This is our Vi. But what we need? Vi by 2. So I am drawing Vi by 2 now. So this is the Vi by 2 waveform guys. Now what will be the output? Just instead of Vi compare with Vi by 2. So let this be minus 1 volt. Let this be minus 2 volt. So what is your answer? This is our answer. It is minus 1 volt. It is minus 2 volt. The only change is instead of comparing with Vi, we should compare with Vi by 2. Why? See, assume guys, if this resistor is not there, whenever the diode is open circuited, this is our equivalent circuit, right? So direct Vi will appear here and we are comparing directly with Vi. But whenever there is a resistor, it is not the voltage Vi it appearing. Vi by 2 is appearing here. So we are comparing with the Vi by 2. It's as simple as that, guys. So this is the next question, guys. In this question, instead of ideal diode, he given silicon diode. So we will see what will happen. Our first step is to open circuit the diodes. See, after open circuiting, since it is a silicon diode, our VA minus VC should be greater than 0.7. Since it is 3 volt here, if our input voltage is greater than 3.7, then only diode will turn on. So indirectly what is happening, guys? If this is an ideal diode, if the input voltage is greater than 3 volt, then the diode will turn on. So our reference voltage is remaining as 3. But if it is silicon diode, if the input voltage is greater than 3.7, then it will turn on. So indirectly our reference voltage is changing to 3.7. Next, here also our reference voltage is changing to, if you see here, guys, the voltage across silicon will be in this direction. So it is opposing 1. So what is the reference voltage here? 1 minus 0.7. That is 0.3 volt. What is the reference voltage here? This is the voltage across silicon diode. We should draw this voltage in the direction reverse to the current direction. So here 3.7 is the reference voltage. Here 0.3 is the reference voltage. So draw 3.7, 0.3 volt. So since it is connected to positive, the positive part which is above 3.7 volt is clipped off. This is clipped off. And the negative part which is below 0.3 volt is clipped off. This is clipped off. So this is the output, guys. It will go up to 3.7, straight line. Since it is 0.3, it will be very low. This is the output. This is 3.7 volt and this is 0.3 volt. The questions which I am solving, they all are previous year question, guys. So practice them well. Next topic is how to find the transfer characteristics. So friends, transfer characteristics is the graph drawn between input voltage and output voltage. It is very simple, guys. If you know how to draw the output waveform, which we have already learnt, then we can draw this transfer characteristics very easily. Just converting this waveform into the graph, that is transfer characteristics. So I will tell you now. See here, this is VB1, this is VB2. So this is the input voltage. From 0 to VB1, the output voltage is following the input voltage. Let this be VB1. See, from 0 to VB1, the output voltage is following the input voltage. That is V0 equal to Vi. Like this. Straight line. And from whenever input voltage is greater than VBI, the output voltage is not following input voltage. It is constant, like VBI. So, whenever input voltage is greater than VBI, output voltage is constant at VBI, like this. This is VBI. So these were the positive half cycle, guys. While coming to negative half cycle, whenever Vi is touching VB2, up to here, V0 is following V input. So let this be VB2. Up to here, V0 is following V input like this. Straight line. V0 is VB2. And whenever V input is greater than this minus VB2, it is minus VB2, guys. Whenever V input is greater than minus VB2, V0 will stays at minus VB2. like this. So these are the transfer characteristics, guys. They are very easy. You can draw this. So I explained only for this. Take the normal series clipper, shunt clipper, and try to draw the transfer characteristics. I hope you will do it. You will do that. With this, the clipper circuit is completed, guys. So guys, if you observe here, we have completed this part today. I explained series clipper, I explained shunt clipper, and similarly two level clipper, and explained the transfer characteristics also. I haven't left one topic. I explained every concept to you guys. And after this, in between, I solved some gate questions also. While solving some gate questions, I explained you some concept. So this part is completed, guys. After that, in next lecture, I will be discussing about this clamper circuits. And after this, previous year gate problems. So guys, if you like my explanation and if you are learning something out of my teaching, do subscribe to my channel, like my Facebook page, and follow me on Instagram, guys. So meet you in next lecture. Thank you.